Hi, everyone. My name is Raleigh, and I'm a program manager with the Google Earth Outreach team. I'd like to welcome you to today's training using Google Earth Engine to help solve for SDGs. The training will be delivered by Justin Brodden, a developer relations engineer on the Google Earth Outreach team. You'll meet him in just a minute. So here's how today's event will work. First, we're going to play the Google Earth Engine training that Justin recorded earlier this month. During the training, please ask lots of questions using the Ask a Question button just below the video. Our trainer, Justin, and I will be keeping our eyes on the Q&A and all the questions coming in. Then after the pre-recorded training, I'll be back on the live stream with Justin, and he's going to answer all of your questions. If we're not able to get to all the questions on air, then we'll answer them by typing in the Q&A below your questions. So remember, please ask lots of questions and stick around to the end to get all your questions answered by Justin live. With that, I'll see you again shortly, and I'm gonna send it over to Justin for the training.
My agenda for today is to give a high-level overview of Earth Engine, the what and the why, and then share some examples of how it's already being used to address some of the UN Sustainable Development Goals to help inspire you. And finally, I'll give you a tour of Earth Engine to help you get started using it. So what is Earth Engine? Well, the short answer is a planetary scale platform for Earth science data and analysis. But that's pretty generic, so let's dig in a little further. First, it's maybe helpful to understand why a platform like Earth Engine exists. Google's mission is to organize the world's information and make it universally accessible and useful. And Earth Engine is Google's platform for handling geospatial information, information tied to a location. There's also others. Two of them that come to mind in particular are Google Maps and Google Earth. And when I tell my family that I work on Earth Engine, they say, "Oh, I love Google Earth." And then I have to explain that Earth Engine is actually something different. I say the difference is that Google Earth is a geospatial data viewer and Earth Engine is a geospatial data calculator. And the distinction's quite great and by design. With Earth Engine, we wanted to help people make substantive progress on global environmental and social problems by empowering scientists and decision makers to generate information from increasingly large and complex data sets. And the key words there are empowered to generate information. The problems we face are complicated and nuanced. We want people to be able to run custom queries and analyses to fit their question or problem precisely. And the way we do this is by gathering and archiving hundreds of environmental geospatial data sets, which at this point totals greater than 50 petabytes in size, which is probably the largest single source geospatial data archive in the world. We attach this data archive to a massive parallel computing system and make it all available through a rich interactive interface. I like to think of it as a data reduction machine. Raw data from Earth and atmosphere observing satellites, like satellite images, as well as many derived data sets go in and information comes out. Information that can be acted on to inform policy and optimize resource allocation, decision-making. It essentially allows you to perform map-based computations, queries, analyses at speeds and scales that are infeasible otherwise. We'll get into the more practical details shortly, but first let's consider the SDGs and how Earth Engine can play a role in helping achieve them. The United Nations Sustainable Development Goals were established as a blueprint to achieve a better and more sustainable future for all people and the world by 2030. Earth Engine is well suited to help achieve these goals since they include a spatial component. Of the 17 goals, Earth Engine is particularly relevant for 8 of them that focus on more environmental aspects like growing food, access to healthcare, and clean water, developing affordable and clean energy, building sustainable communities and cities, climate action, and wildlife and land conservation. In fact, many research institutions, governments, NGOs, businesses have been using Earth Engine to make progress on these goals. So let's take a look at a few examples. Here we have an example that addresses Goal 15, Life on Land, where researchers mapped global forest extent and change over the last 20 years. Cataloging where forests are and where they are most susceptible to being lost can help with prioritizing regions for conservation, to restore or preserve habitat, and to help maintain biodiversity. In this example, a researcher has developed a data set and app that can help optimize for siting of green infrastructure. Where is it most needed in cities? This addresses SDG 11, Sustainable Cities and Communities. Next up is a data set developed by the Joint Research Center that tracks global surface water extent and dynamics for 3 decades, which supports SDG 6, targeting clean water and sanitation. And here's an example that could be used to address SDG 2, Zero Hunger. The platform OpenET uses Earth Engine to map evapotranspiration to help farmers and water managers optimize irrigation for more sustainable crop production. And here's Global Fishing Watch. This group uses Earth Engine to map fishing vessel traffic in an effort to identify illegal fishing activity and also monitor fishing pressure to enable fair and sustainable use of our oceans. This last example is pretty unique. The previous examples address SDGs of a more environmental nature, but this one addresses a social issue, access to healthcare. So a research group produced global maps of motorized and non-motorized time to reach a healthcare facility. This information could be used to optimize the location of new facilities to help ensure equitable access. So let's do a live demo of how you might use Earth Engine to begin solving an SDG. Let's use the access to healthcare data set. Our goal will be to identify the top 10 locations globally to build healthcare facilities to make the greatest impact. Our inputs will be drive time to healthcare facilities, that data set we just saw, and also we'll incorporate population density. Our output will be 10 small target regions as polygons where we would advise the building of new facilities. And the analysis will include filtering the 2 data sets, 2 inputs, to the greatest need, regions where drive time is greater than 30 minutes. It takes a long time to get to a facility. And also that there are at least 50 persons per square kilometer that we want to make sure we have an impact. If there's only 1 person living in a square kilometer, it has less impact. So we'll focus on areas that are more dense. And after we have filtered the data to those criteria, we'll calculate a need score based on density, population density, and summed regional need. And from those scores, those need scores, we'll delineate 10 regions with the highest need score. Now, the place where most analyses start is the Earth Engine data catalog. So I'll head there now. If you do a Google search for Earth Engine data catalog, you'll find it, but I already have a tab open. So let's get going. So here's the Earth Engine data catalog. This is where you can go to find and explore all the data sets that are available in Earth Engine. It includes streaming satellite image data sets that include historical up to near real time that are being updated by the minute in some cases. And there's also a lot of static data sets. Think of like elevation or population that might be a snapshot from a census and isn't updated so frequently. On this homepage, it gives a listing of some of the data sets that are available: atmosphere and weather, imagery, and geophysical. That includes terrain and land cover, croplands, and here's an image of nighttime lights down in the lower right. So most analyses start out here in the data catalog. We need something to work with, some kind of raw data to start our analysis. And we're interested in working with the accessibility to healthcare facilities data set. So to find a data set, we can go to Browse by Tags and search for keywords. You can see that there are a lot of them here. And if we type it in, it will narrow down the search to one of these keywords or multiples. So I'm going to type access. There's a tag for accessibility. If I click on it, I can see the two data sets that are tagged with accessibility. And this is the one we're interested in, accessibility to healthcare in 2019. So I'm going to click on it, and I would be here trying to learn a little bit about this data set. Does it suit my need? And I'll read and maybe want to learn about limitations to the data set, methods for how it was gathered and published, which are all really important for understanding what kind of analysis you can do and the kind of caveats that you should include with your results. So on these data catalog pages, we can find out when the data was published. We can find out who published it, how we can import it into Earth Engine. There's a small code snippet, the tags that it includes, the description, the types of information that are included with the, in this case, image data set. We can see that when we're looking at the imagery, the pixels, their value are in units of minute. And we have two different bands. One is accessibility, and the other is accessibility walking only. And we can read about what those mean exactly here in the description. And then also it includes a snippet of code to help you get started working with the data or visualizing it. I have a script already coded up, so I won't be using this one, but there is a convenient feature. If you click this button here, open in the code editor, it will open a new tab in your browser, and this code will be present already in that tab in the Earth Engine interface. But since I already have a script coded up, I'll just move over to that tab, and we'll get started looking at this data set. So welcome to the Earth Engine interface. This is where we do our coding. So, you know, I had said earlier that with Earth Engine, we want to allow people to do very precise queries and analyses. And the way that we do that is by writing a set of instructions for Earth Engine's computers to run on the data set. And the way that we're doing that is we're packaging up bits of code using the JavaScript programming language. But actually, we don't use much JavaScript. It's basically all Earth Engine code. So Earth Engine has about 1,600 functions to import, analyze, and export and visualize data. So most of what we do is simply kind of coding in what you could call the Earth Engine language. So some of the components of the interface include the script editor. This is where we write our instructions for what we want to do with the data. Below it, we have the map viewer, and this is where we can draw shapes to analyze a particular region of interest. We can visualize our data analysis as image layers or as feature layers. To the left, we have our scripts panel. And so scripts that you've written in the editor, you can save them and share and manage them here in this tab. We have a documentation tab that describes all of the objects in Earth Engine. And these objects all have a set of methods, the things that you can do to them. You know, so we've been talking about image data, you know, pixelized data. So if I drop down this list of methods for image, we can see all of the different things that we can do with image data. And we also have an assets tab. This is where we can manage our imports and exports of image data and feature data. And then over on this right panel, we have a console where information about our queries can be printed. We can inspect the map by clicking on it. And if we export some data, we can look into this tasks tab and see how our exports are going. So let's dig into this problem a little bit in our script. So we had said that we want to identify the top 10 places to place a medical facility to increase equitability for the most at-need regions. And the two data sets that we're using for this are the time to a facility and population density. So let's just take a look at what those two look like in the map. So I have the time to access healthcare facilities, and the color here grades from dark to light, where dark is a really short time to healthcare facility, and light colors are a long time. So you can see that up in the Arctic, it takes a long time to reach a hospital or clinic. And near large cities, where we see that it's dark, in more populated areas, it takes less time to reach a healthcare facility. And now let's look at population density. So here we can see that we have a gradation from dark to light, where dark is really low population density. Again, if you look at the Arctic, there's not many people living up there. And it grades to a light color, where there is high population density, lots of people living in the same area. And we can change the transparency of the population density, and we can see that there's a correspondence between drive time to a healthcare facility and population density. So this is kind of a big problem. There are lots of areas based on access time to a healthcare facility. There's a lot of areas that it takes a long time to get there. So we want to narrow this problem down. And we also understand that there's a lot of places where there's not many people living, so we can use that information to have the greatest impact. We want to be able to help as many people as we can, and be careful about the resource allocation that we have. So let's break the problem down a little bit. We can do a query that says, based on our time image, tell us all of the pixels that are greater than 30 minutes. Like, that's too long to get to a hospital. So, let's focus on those areas first. And if we look at that, we can see all of the places in purple, it takes greater than 30 minutes to get there. So these are places where we would potentially want to focus on to put a facility. But as we've mentioned, a lot of these areas are in the Arctic and in places where people aren't living. So we also want to restrict this a little bit further. And we want to say that there should be at least 50 people living in 1 square kilometer in order for us to be interested in it. So, we want to be able to make a big impact. So if we applied that kind of filter, we can see now that it's a much smaller, regions around the world where this kind of criteria matches. And so we're talking about data reduction. We're sort of reducing this problem into a manageable size. So at this point, all of these regions are weighted equally. We just know that these are areas of need, but we still want to make the greatest impact that we can in these areas of need. And we can maybe do that by normalizing this data based on, or weighting it based on the population density in these areas of need. And by doing that, we can develop a need score. So each pixel, and the pixels in this case are 1 square kilometer. So we can develop a need score for every 1 square kilometer in these areas of interest. But we also maybe want to consider a regional extent around each of these pixels, to make sure that we're able to help the most people in sort of a larger radius around a given point, sort of. So to our score, or what we'll do with this score is add up all of the need within a region, and then we'll have this need score. And what we'll do is we'll find the 99th percentile, the highest need score, and we'll draw polygons around them. Well, we won't, the computers will. And then from those 99th percentile polygons of greatest need, we'll sort it by greatest need and just pull out the 10 that need the most help. And so I can add this need score, and if I zoom in to a region, it grades from light to dark purple. And so dark purple is areas of high need. And as I was describing earlier, we want to kind of aggregate this need among regions. So we'll do a moving window analysis where each pixel will be looked at, and the surrounding 25 kilometers around it, all of the need will be summed up and assigned to the central pixel. And in that way, we can incorporate sort of regional need along with the need at that specific pixel. And after running that, we can identify our top 10 locations, and they'll appear in yellow. So this is still loading. We can see that there's a load bar here, and it's almost completed. And it has identified regions in Iran, Uzbekistan, Pakistan, China, and North Korea. Also in the Sudan. So this is a little bit of a quick kind of back of the napkin analysis. And there's sort of lots of caveats here. And there's also different ways that you could slice this data and other data sets you'd want to bring in for consideration. But I just wanted to give you one quick example of how within, about 50 lines of code, we can roughly identify areas in great need of a hospital facility. And we could provide this information to, managers and government officials in these places as a place that you would maybe consider putting healthcare facilities. And once you're happy with an analysis, a really nice thing that you can do is make an app out of your analysis. A convenient way to share with people what you've found and learned and let them explore for themselves. And so we have a thing called Earth Engine Apps. And it takes essentially the script and the outputs that we have here and wraps them up into an interactive interface where there's no code showing, and users can use sliders and exploring tools to look at the data that you have generated and the analysis that you've done. So here, for instance, we're looking at a region of flooding based on, I believe, synthetic aperture radar data. On the left panel is this region of Earth prior to a flood. And then if I slide it over, we can see all this light blue, which is water, has inundated this region. So this is a nice way to allow people to quickly interact and visualize your data. Another neat example is being able to chart a location. So we'll look at ocean temperature in this example. So we can render the map data. It's still drawing. And this is happening in real time. A script has been sent to Earth Engine servers, and it's asking for ocean temperature to be colored along this gradient from dark blue to light blue, tied to the values 0 to 30. And it's retrieving them and sending them back to you in real time. And I can also click a location, and you'll see that this time series chart of ocean temperature will update for whatever region I click. And again, this is happening in real time. A request is being sent to Earth Engine servers every time I click, and the result is being sent back to the browser in the form of a chart. So now that you've seen how Earth Engine starts, the next step for getting going is to register as an Earth Engine user. So Earth Engine is free for research, education, and nonprofit use, and you can sign up at signup.earthengine.google.com. And with your account, you get 250 gigabytes of storage, and that can include 10,000 assets. The next step is to visit our user guide. We have an extensive user guide that explains everything about Earth Engine and provides many examples of code for getting yourself started. So with that, thank you, and we'll take questions.
Wonderful training. Thank you, Justin. And hi to everyone. Welcome to the live Q&A portion of today's event. Thanks for sticking around. We have a bunch of questions already from the audience to answer. It's not too late. If you still have a question, please submit it right below the video. See the blue Ask a Question button. And we'd love to answer them all. So Justin, thank you for sticking around. Thanks for the great training. Looks like we've got a lot of great questions to get to. Are you ready to get started? Oh, and I think you're muted.
Of course, thanks.
Classic. All right, so the first question that we've got here is from Stace Maples. So Stace says, love the sample script, which I can use with my own students. The distance layer is cool. Is there an easy way to make distance layers from your own feature sets, points, lines, polygons? For instance, if you're interested in access to water or to schools or something else.
Yeah, that's a great question. And I did fire up a little demo while the recording was going. Maybe if we could switch to my screen. This is really basic, but if you had featured data, like points, lines, polygons, there's a really easy way to do that with this distance method. So what I've done here is I've just dropped in, a handful of points. And you can do that with the drawing tool, or if you have uploaded data as a shapefile or something, it might appear the same way. And then I've set those points to be a feature collection. And then I tell it the search distance I want to look for between these points. I've just put 100 kilometers here. And then I run the calculation and display the map results. And you can see, regions that are yellow are very close to the point. And as you get further away, the color is blue, the distance is greater. So yeah, there's the distance tool. The analysis that I did in the script is slightly different. That one wasn't based on points, polygons, vector data. This is probably the most convenient method if you can get your data in vector mode.
Awesome. Thank you. Okay, so our next question is from Advin, who says, I used Google Earth Engine for land surface temperature, and while I got some useful values, my output also had NaN, not a number, which didn't help my research. So it's more of a comment, but I guess, it leads me to asking the question, like, why would you get not a number in your output? Is there anything that people can do to address that or mitigate that? Your thoughts on that.
Yeah, often not a number or null results from masked values. So for instance, if you are doing a calculation on temperature, I'm not sure what data set they're using, but sometimes the temperature data sets can be flagged, pixels can be flagged for quality and masked out by default. And so if you're doing like a region reduction, if you want to know the mean of the temperature in a certain area, and for some reason the data in that area on a given date, maybe it was all flagged as bad data, those are going to be masked pixels. And then when you run your reduction, there's no values to get the mean for, so a null is returned. So often it's the case that there are masked values, and you should try to look at your source data to see if that is in fact the problem, and generally it is. And in that case, you might composite a larger date window, look at temperature over a larger range, or maybe switch to a different temperature data set. Yeah.
Great suggestions. Thanks, Justin. Okay, so then our next question is coming from Kim from Cameroon. Kim asks, you mentioned the analysis of ET to help farmers. Do you validate the study using ground truth data? If yes, how or what are the differences between satellite and ground truth data results?
Yeah, so in that particular case, I was talking about this group OpenET, and we worked with them to generate the data, mostly just helped them get through their processing workflow. And they have published papers, I believe, and have a methodology for validation, but I can't tell you the details of that, but I recommend that you go to their website. If you just Google search for OpenET, you'll be able to find more information.
Is the link that you put in reply to Kim's question, the openetdata.org, is that a good link to use?
Yeah, that's very generic. It's just their homepage, so you have to do a little bit of digging. But I know that I've seen where they have listed publications and methodology.
Awesome, thank you.
Yeah, and in general, the data sets that we host, Earth Engine and Google are generally not developing them. We are generally hosting data sets that other people have generated and that have been peer reviewed. So you can pretty well trust that most of the data sets in the data catalog have some validation, and you'll be able to find out what their methodology and what the results were.
Thank you. Okay, next question is from Emil Charrington, who says, awesome presentation, Justin. And in your perspective, in addition to the vast volume of data available in Earth Engine, are there other data sets you'd like to see integrated into Earth Engine that you consider to be critical for SDG tracking?
Yeah, I think, I mentioned in the write-up there that we don't have a lot of social economic data. I'm not very familiar with that. I'm sort of a environmental geoscientist, but I assume that there are many databases for groups that are tracking, more sort of tabular data at like city or county level, things about poverty and income and hunger and education levels, programs in cities for recycling or, renewable energy. And a lot of those things are SDGs, are in the SDGs, and we don't cover them very well. A lot of them are tabular data. It seems like a lot of Earth Engine's focus is on raster data from Earth observation satellites. I think that Sam Roy, who was also mentioned in the chat, is doing a really great job of hosting data sets that anybody can upload, can share with him and request that it be uploaded. And I think that that's a good opportunity to get more data into Earth Engine, is through sort of community hosting efforts. There's a lot of barriers to getting data into Earth Engine, and the time horizon is quite long, and there's a long request list. But there's definitely opportunities for the community if there are important data sets that can be hosted by community members and shared. I think that is a good way to approach this problem.
Great. So I'm going to switch to a question from Nicholas that I think kind of goes back to the demo that you did during the training. And Nicholas says, I'm curious to know, is it possible to calculate the distance between the hospitals?
Yeah, I mean, so you would do it, well, we don't have the hospital data set, the locations in Earth Engine. Well, the raw data there is distance, is drive time between hospitals, or if from any location on Earth, what is the distance to the nearest hospital is sort of the raw data set. So it's not distance, but drive time. So it's not distance, I guess, but it's close. And the hospital locations are available as a vector data set that could be uploaded into Earth Engine. And you could calculate the distance between them using the same example that I just demoed here with those handful of points. Yeah, so right, you could find that data set. I don't know how much detail I want to go into. If you look into the data catalog and you look up distance to hospitals or drive time to hospitals, you'll find that data set. And in there, they provide the database where they drew sort of their source hospital locations from. And you could upload that data set into Earth Engine and then perform this distance analysis there.
All right. Next question. Do you ever see a day when Google Earth Engine makes proprietary data assets, thinking specifically of PlanetScope, directly available for users with rights to them in Google Earth Engine? I know Planet uses GCP for its processing, so it seems like it should be possible. This is from Space.
Yeah, we have a project right now, Dynamic Earth, which is predicting land cover for every single Sentinel-2 image. And that would be, I guess, a sort of a proprietary product. It will be open access. I'm not sure what the license will be, but you'll be able to access it through Earth Engine, certainly. And that is probably that would be like sort of the showcase of a data set that is sort of generated in-house by Earth Engine and made publicly available. There's a team of scientists and researchers within Google who have submitted this work for peer review. So it will be available in the data catalog just like all the others that have been peer reviewed. I hope that kind of addresses the question.
Thanks, Justin. Okay, now we have a couple of related questions. So the first is from Emil. In addition to this being a great presentation, it's just a great topic. Does Google also have any plans for lightning talks from the user community on this issue? We've seen some great work from colleagues like Rafael Monge, I'm not sure if I'm pronouncing that right, from Costa Rica, and their Group on Earth Observations Earth Engine project, for example. This probably is more directed at me than you, Justin, so I'll take this one. So yeah, for those who don't know, we host almost monthly lightning talk series on this events platform where we do featured talks from Geo for Good community members on how they're leveraging geo tools to address big social and environmental problems. And we're actually in the midst of planning out like our calendar for the 2022 year. So that is a great suggestion, Emil. I think I will take it. I think it's a fabulous idea. And if others know of projects that they would nominate to be featured in such a lightning talk episode, please, add comments or contact us. But yeah, I think it's a great idea. Then kind of on a related note, Brian asks, I don't know what the plans are for this year's Geo for Good, but are there plans to build on this training in the near future? I'm in an SDG working group with several colleagues at my university that are just starting to dip their toes into data science. I'm hunting for good trainings and resources for them, so I'm not their only resource. They'll be much more likely to log into anything with the explicit SDG focus. This is from Ryan Good. So yeah, I mean, we are definitely, starting the planning for this year's Geo for Good and always looking for good ideas for training. I'm curious, actually, Justin, do you want to talk a little bit more about why you decided to focus this training on SDGs and whether there's any potential to grow this into a bigger training for a future event like Geo for Good?
Yeah, this started with a request from Google Developer Student Clubs. It's sort of like a hackathon, but I think it's less about competition. Anyway, it's sort of a coding club within Google, and they have challenges that they use Google technologies to solve the challenge with. And in this case, this group wanted to address the SDGs. And Google Earth Engine is just right in the wheelhouse for addressing SDGs. So I gave this talk to that group. Excuse me. So it just seems like there's a lot of interest in solving for these SDGs, and I think the goal is by 2030 originally. And so every year we're creeping closer, and yeah, I'm in full support of this. It's a very applied thing that we can direct our trainings at. And it would really help to have the community involved. What kind of data sets and expertise can you bring to the technology? We can provide computing power and data sets. What kind of science and questions can we help you answer with this? Often, the Google Earth Engine and Earth Outreach teams are here to facilitate, maybe not domain experts ourselves, but looking to help facilitate. So if there's ways that we can help organize, and you can help us organize, that would be great.
Yeah, I could see kind of a bit of a dream team, maybe co-teaching a class at GR for Good or some other event, partnering someone from our DevRel team, like yourself, and someone else who's like the subject matter expert in whatever SDG. For the GR for Good application, we generally have a section on there where you can propose a talk. So if you are watching and you are a subject matter expert in one of these areas or know someone who is, maybe think about proposing a training on this topic at GR for Good this year, because I'm sure our DevRel team would like to partner with you in teaching that.
Yeah, we're always looking for applied examples that can make an impact.
Wonderful. Cool. Great ideas. I have a lot of ideas now for future events just based on the suggestions from the audience. Let's see. I think we have time for maybe one or two more questions. I'm looking to see if anything comes in live. Not seeing anything yet. So I'm just going to kind of go back to like a beginner question that I have for you, Justin. So if someone's really new to programming and they're familiar with Python, do you have any advice for how they can get started using Earth Engine the quickest?
Use JavaScript instead. We have a Python API, but if you're learning Earth Engine, I feel like it's hard to get started with using the Python API. If you're just learning Earth Engine, mostly because the code editor where we do the JavaScript API is so integrated with the map for outputs, the console for outputs, for being able to inspect values really quickly. There's documentation integrated right into the IDE, the development environment. Imports are so much easier. You can search the data catalog right from the code editor. So starting your development of scripts and debugging and sort of understanding the mechanics of Earth Engine is just a lot easier in the code editor. And there you have to use JavaScript. But the cool thing is that most of what you write is not actually JavaScript or Python. It's just, sort of the Earth Engine language, our API. It's really rich. There's over 1,600 functions. So pretty much everything that you'd want to do, you do with the Earth Engine language. And so I think the best place to start out is in the code editor. And if you're moving into more production code after you've established your script, you can pretty easily translate it to Python to run things maybe in a more automated way. Also, definitely check out the developer guide. Dusty, maybe if you could switch me over to the developer guide. So we have really extensive pages on how to get started. There's a section on getting started here, which walks you through most of the objects that you can work with in Earth Engine, image collection, features, and the kind of computations you can do and how you can visualize, how you can export data. So spend a lot of time initially working through these documentation pages. There's lots of examples. And once you've had a sort of a feel for how Earth Engine works in general, then I would switch over to asking questions in Google search, just specifically searching for your question or problem, and you'll probably get a response from GIS Stack Exchange. There's almost 3,000 questions and over half of them have answers. So likely you'll be able to use GIS Stack Exchange to also help you do an analysis, once you have a feel for Earth Engine using the developer guides here.
And Justin, we have a shout out on the Q&A forum for Tyler Erickson's Python notebooks. Is that something linked to from the developer docs you were just showing, or where would people find those?
He has a so on GitHub, there is an Earth Engine community section, and Tyler has some notebooks there. There's a notebook here on how to get started with Earth Engine. If you click this in Colab, you can see how to start getting an Earth Engine. Also, we have community tutorials that are specifically for Python. And also, probably the best way to use Python with Earth Engine is to use GEE map. It's basically the code editor for Jupyter notebooks. Qiusheng Wu has developed this and has a huge following and is really great supporting it. He has a bunch of YouTube videos to help get you started. So if you're interested in working with Python and you're not interested at all with the code editor, this is probably a good place to start, is with using GEE map.
Awesome. Well, thanks, Justin. Thanks to everyone watching for all the questions and the suggestions in the Q&A forum. I want to say thank you to everyone for joining today's session, and we hope to see you at a future event soon. Take care, everyone, and have a wonderful day.